Hi, everyone. We are continuing with chapter 5.3 today in this video. And this second video of the section is going to be logs versus exponentials. So we've kind of defined logarithms and exponentials a little bit already. And so we want to think about expanding that idea, like the connection between the two things. And the way we're going to do that is by thinking of them in terms of inverses of each other. So I'm going to write here at the top a bullet point here. Logarithms and exponentials are inverses. So what that means in terms of what we've talked about before is that if I were to graph both, which we'll look at later in this chapter, they're going to be reflections of each other across y equals x. But for right now, if I had a exponential form equation, really general one, just letters, it might look like y equals b to the power of x. So if I wanted to find the inverse, I need to figure out, well, I need to swap x and y and then get y by itself again. So the steps to do that was like I would first swap x and y. So x would be equal to b to the power of y. And then if I wanted to get y by itself, well, that exponent, it's important to remember, like the answer to a logarithm is always going to be the power or the exponent part. So this y is going to be the answer part to the logarithm side over here. So I know that y is going to be my answer. The base b is going to be on the bottom there, base b. And then our input is x right there. And this goes back to our last video where we were looking at how to go back and forth between these two things. And that's going to be the first thing that we talk about. And remember that you read this logarithm as log base b of x equals y. So if I were to graph this equation and this equation, you could tell very obviously in the picture that they were inverses, but we're going to come back to graphing at a later date. So as far as converting them back and forth from each other, let's look at some examples. So the main topic here is converting from a logarithm to exponential. And the way we're going to do that is we'll start looking at some examples. So first example here is we have log base 15 of 225 is equal to 2. So let's remember about our water lilies in our last video. We have a growth rate of 15, and we want to see, well, after how long is it going to be 225 times as big? Well, we can figure that out. Well, we know that it would take 2 times to get up to that number. 15 times itself twice will get me 225. And we can rewrite that as 15 as the base, power of 2 equals 225. A good trick to remember here is to draw some arrows to help you remember. So it's like 15 squared is going to be equal to 225. And those arrows will help you to remember it really easily. And I think that's a really effective way to do it. 2 more examples of this. we could write something like log base 3 of 1 over 27 equals negative 3. So if we draw in the arrows, well, we would see that we could write it as 3 to the power of negative 3 equals 1 over 27. And we could even check that in our calculator to see if that's actually true, if we set it up correctly. 3 to the power of negative 3 equals that. Let's change it to a fraction. And we can tell that that's correct. So what we just did was an accurate thing to do. And last example we have is a little bit different. We have log base 4 of 32 is equal to 5 over 2. So if we draw our arrows, 4 to the power of 5 halves equals 32. And we can just write it exactly like that. 4 to the power of 5 halves equals 32. And we could check that in our calculator as well, but it is in fact true, even if it has that rational exponent, fraction exponent. Next, we're going to talk about going from exponential to logarithmic form, which is a little bit harder, but we just need to remember the key words here. So we just need to remember that the 2 right here is the base. And we need to remember that the 7 right here is the exponent. And the 128 is the result. And we're going to write that in a second as log with a base of our result equals the exponent. So if we want to do that for this problem, well, we would just write it as log base 2 of 128 equals 7. Got to figure out, well, how many multiples of 2 do we need to do to get up to 128? Well, we know that 7 of those will get us up to 128. And so we know that those two are equal to each other. They are equivalent. The fifth example, we would have a 3 to the negative 4 equals 1 over 81. So we know that the 3 is the base, 1 over 81 is the result, negative 4 is the exponent. So we have log of the base 3, base, bottom, our result, and always remember that the answer to a logarithm is an exponent. So it would be negative 4 as a result there. For number 6 of this, we have 64 to the power of 2/3 is equal to 16. And well, if I put that in my calculator, well, I know that's true. 64 to the power of 2 over 3 equals 16. And all I just need to remember is the base is 64, log base 64. The answer is going to be my exponent, and the only thing left is the result. A different way to think of it, but it's a good way to remember what order they're going in. Now, the last part of this section is going to be evaluating logarithms, and some of the problems will be very straightforward. One we actually did earlier in our first video is this one right here. You're trying to evaluate what the log base 3 of 81 is going to equal. So in this problem, what I would probably do is first, well, I know it's got to equal something. It's going to equal some unknown answer, x. And I think the easiest way to figure it out is just convert it to an exponential. That's why we're doing this last. So if I'm from my arrows here, 3 to the power of x is going to be equal to 81. So 3 to the x equals 81. Well, I can just do that in my head. 3 times 3 is 9, times 3 is 27, times 3 is equal to 81. So I know that x is just going to equal 4 because 3 to the 4 equals 81. This next problem takes one step up in difficulty, and we want to equal x first, but then we're going to convert it. 2 is the base, x is the exponent, 1 over 16 is equal to it. Some of you guys might be able to just know, well, what the answer might be just by looking at that, but let's say that you didn't. A way you can think about it is, well, 2 to the x is staying the same, but I want a common base. So I could write it first as 1 over 2 to the 4th, and that would be the same thing as 2 to the x being equal to 2 to the negative 4. Well, now that I have a 2 on the bottom of both sides, I know that the answer for x has to be negative 4. And then if I want to see if I'm right, I can just check to confirm that 2 to the negative 4 is equal to 1 over 16. Third problem is log base 9 of 1. We want to figure out what that is equal to. So we can draw our arrows again maybe and do 9 to the power of x equals 1. That hopefully is obvious. Well, and if I'm getting it to 1, 9 to the power of 0 equals 1. And that just means that x is 0. And remember that that means that we are saying that log base 9 of 1 equals 0. And that's really what we're doing here. We're trying to evaluate the actual logarithm. Now, this last problem of the video will be a little bit more challenging, but nothing we haven't really seen before. So we could say that this is all equal to x, and that 8 to the x equals 4. And I can write that off to the side here. Well, 8 to no power we know off the top of our head is going to get us 4 since it's smaller and not quite so familiar. So what we have to do is make them the same base. So I could write this as 2 to the third and 8 are the same, and 2 squared and 4 are the same. And then it's using exponential equation skills. Well, 3 times x would make it so I have 2 to the 3x equals 2 to the second. And well, if those 2's are the same, that means that 3x and 2 are equal to each other. And that means that x is equal to 2/3, meaning that our original problem, log base 8 of 4, is equal to 2/3. And that is the intro to logarithms. That is what 5.3 is all about. And now we've kind of talked about where they come from and how to convert them back and forth between exponentials and logarithms. Finally, we looked at evaluating them and trying to figure out what logarithms are going to be equal to. And I will see you all in the next video.